Last time, we connected AX equals 0 and AX equals B to null spaces and solution sets. Today we define RREF, then use it to find A inverse for a 3 by 3 invertible matrix. The trick is not a trick. It is elementary matrices doing paperwork in the background. Naturally. RREF stands for reduced row echelon form. It must already be in row echelon form. Every pivot must be 1. And each pivot column must have zeros everywhere else, above and below the pivot. So RREF is echelon form after the cleanup crew arrives and removes the remaining mess. Now let us explain why row reducing A beside the identity matrix finds the inverse of A. When we row reduce A, each row operation is left multiplication by an elementary matrix. If those row operations turn A into the identity matrix, then their product times A equals I. That means the product of those elementary matrices is A inverse. Putting I next to A lets the same row operations act on I. So the right side becomes that product, namely A inverse. Now let us do a concrete example. We will use this matrix A. To find A inverse, put A beside the identity matrix and row reduce. The left side is the matrix we want to turn into I. The right side quietly records every row operation. Sneaky, but useful. First, use the top left pivot to clear the entry below it. Replace row 3 by row 3 minus row 1. This produces a 0 below the first pivot. Remember, the same operation happens on both sides of the vertical bar. The identity matrix is not just watching, it is being transformed. Now use row 2 to clear below the second pivot. Replace row 3 by row 3 minus row 2. Now the left side is in row echelon form. But we need RREF, not merely echelon form. So now we clean above the pivots. The algebraic janitor returns. Start by clearing the entries above the last pivot. Use row 3 to eliminate the entries above the pivot in column 3. Replace row 2 by row 2 minus row 3, and row 1 by row 1 minus row 3. Now column 3 has zeros above and below its pivot. Finally, clear the entry above the pivot in column 2. Replace row 1 by row 1 minus 2 row 2. The left side is now the identity matrix. So the right side is A inverse. Now read off the inverse from the right side. For this example, A inverse is this matrix. Multiplying A by this matrix gives I. That is the sanity check. Mathematics occasionally allows those, usually after making you earn them. What if row reduction does not turn the left side into I? If the RREF of A is not I, then A is not invertible. In that case, A inverse does not exist. A missing pivot means the map loses information. And lost information is not something an inverse can magically recover. Tragic, but fair. Let us summarize before the inverse pretends it was obvious all along. RREF is row echelon form with pivots equal to 1 and pivot columns cleaned above and below. To find A inverse, row reduce A next to the identity matrix. This works because row operations are left multiplication by invertible elementary matrices. If the left side becomes I, the right side is A inverse. If not, no inverse exists. Next time, we can keep turning row reduction into actual computational machinery, because apparently one useful algorithm was not enough.